Hi, it's me, Jazzy. I'm back with another tech-related video, and today I'm taking a look at a new product from Zoyi. Now, you may remember the ZT-MD2 LCR Tweezers. I use them all the time in kit builds, and they're a really handy thing to have on your bench. Well, Zoyi have now come up with a new version, the ZT-MD2, which promises a few little extras. Yeah, it's got the ability now to measure voltage as well as capacitance, resistance and inductance, and it's got a built-in signal generator. What? I hear you say? Yes, I kid you not. Let's get this beauty over on the bench and take a look what we got. So you've all seen me using the Zoyi ZT-MD2. I use it all the time on my kit building videos, and it's a really cool device. I think it's really good. It's fast, accurate, quick and easy to use. Now they've come up with the new one, which is the ZT-MD2, which they reckon is even better, if that's possible. So big thanks to Zoyi for sending this over for review. Now this adds up to 100 kilohertz testing on inductance, capacitance and resistance measurements, whereas this one only did 10 kilohertz. It also adds up to plus minus 16 volts DC measurement and a signal generator. What more could you want? Well, let's have a look. What do we get in the box? Well, you get a nice little case. It's always useful to keep your tweezers in. Mine are always on the bench all the time. Now, let's have a look. Oh yeah, here we go. The ZT-MD2. The main difference straight away is this CNC machined aluminium alloy, or aluminum alloy if you prefer, which does make it noticeably heavier than the MD1. It does say on the back, use prohibited for non-professionals. Do not measure voltages above 36 volts. I'm pretty sure it mentions plus and minus 16 volts. Does sit quite nicely in the hand, but you do notice the extra weight. Let's see what else we get in the package here. So we've got some instructions. We've got our charge cable, USB-C to A as normal. We've got a little instruction manual here, and we've got a little, I think this is like a little tester, so you can do some tests of these like little tiny surface mount resistors here. Look at that. Oh, so you've got 0 ohms, 1 ohm, 10, 100, 1k, 10k, 100k, 1 meg and 10 meg. Okay, that's interesting. That's actually quite a useful thing. Depends how accurate those resistors are. We're going to find out. Right, here's all the specifications, so you can freeze frame that if you want to take a look at the specs. There you go. Right, so let's power this up, shall we? Okay, so obviously I will be comparing it with the MD1. So you can see we've got a bigger display there, whether you prefer those digits to those. These are the more traditional digits that you would see. So if we run through the functions on this one, so short press on the power button does hold on and off. Long press obviously powers it off. Now this changes our mode. Now this is very intuitive because it's right above where the mode is on the screen. So you've got inductance there, diode mode, voltage, that's new. Oh, we've got a scan, frequency scan. Interesting. That's our signal generator there. We'll take a look at that in a moment. That goes into auto or back to resistance. Right, okay. And here we've got our voltage. So you can swap between 0.1, 0.3 and 0.6 volts. So your test frequency there, so you can go from 100 to 120 to 1k to 10k to 100k. Long press on there takes you into the menu where you can change your language. You can change the direction, right, left or auto. And you can change the backlight amount. You can change the volume of the beep. And the off timer, you can either turn it off or you can set it from 5 minutes to 120 minutes. The test speed you can change from slow, mid to fast. The mode of your testing, you can switch between auto, serial and parallel. And this is your secondary parameter here, so you can swap between all these other parameters that you'd normally have on an LCR meter, or you can just have it on auto. And then your functions there, you can calibrate these, you can restore to factory settings, and that tells you the version number. Oh, you can see that it automatically swaps which way up you've got it. Quite cool. Sometimes when I'm videoing, I'm working at really awkward angles trying to get the device on camera, so it's quite nice that it actually turns the screen round like that, quite like that. Okay, so what's the major differences then, I hear you ask, between these two models? So the MD1 featured an OLED screen, whereas the MD2 has a 1.47-inch TFT screen. The housing on the MD1 is made of ABS. The newer model is a CNC aluminium or aluminum alloy. Frequency-wise, test frequency on here only went up to 10 kilohertz, but on the new model you can actually go up to 100k. I like the fact this is really intuitive with the buttons, because the frequency button is right above the frequency display, the voltage button is right above the voltage display, and the function button is right above your function. I like that. So the other extras with this one, they've obviously added the DC voltage measurement up to plus minus 16 volts and the signal generator function. And in the secondary parameters, you can also look at phase angle now, which it didn't have on this one. Now they've given this little strip of resistors here with the MD2, so I feel it's only fair if we have a test with this. All right, let's have a go, shall we? So let's start with 10 meg. 10.1. Okay, 1 meg. Yep, it's pretty quick, isn't it? That's good. 100k. Yeah. Yep, excellent. Okay, 10k. Obviously don't know how accurate these little resistors are, but looking pretty good. 1k. Yeah, all right. 100 ohms. Wow, pretty good. 10 ohms. Yes. Okay, a little further off on 10 ohms. 1 ohm. All right, 99, okay. All right, just under 0 ohms. We are getting, okay, 1 milliohm. All right, I've not done any calibration or anything with this. This is factory fresh, so I want to see how it performs straight out of the box. We'll have a quick go with a couple of resistance and capacitance decade boxes, and then we'll have a look at the extra features on the MD2. I'm looking forward to trying the signal generator out on this. Okay, so quick test on my decade box. This is the one I always use for testing. Now, if you long press on key 3, we'll rel it out. Okay. Near as damn it. Right, 1 ohm. Okay. 990. Okay. 10 ohms. Alright. Pretty darn good. 100 ohms. Yeah, bang on. 1k. Yeah, not a problem. Okay, so not quite so easy to get a connection on this box because of the distance between these two terminals, but we got it, we're okay. So I can go with 100k on here, and we got straight away 99.86k, and let's go with 1 meg, and we got, yeah, bang on, near enough, near as damn it, that's not bad. And 10 megs, yeah, not a problem. Okay, it's nice and quick. I like how fast and responsive it is. All right, let's have a quick try on capacitance then. Let's see if this picks up the 160 picofarad residual of this box. Oh, that's quite convenient. And yes, can I say I'm impressed with this? 158.6 picofarads. Bearing in mind we've got that 160 picofarad residual, we can do 1 nanofarad, and that is absolutely spot on. 10 nanofarads, fantastic. 100 nanofarads, absolutely spot on. This thing's amazing. It's not even mega money. I think it's around the £40, £30–40 mark. You can probably get deals. It's around on AliExpress at the moment. But I've got to say, 1 microfarad, yes. And I know this box is incredibly accurate, because I've checked it out against others, and that is impressive. That is really impressive for the money. And as I always like to do, 10,000 microfarad test. Let's have a go. It's going to take a while. It's a big cap to charge up, this one. It will take time on a capacitor this size. It will take its time, but yeah, we are around 9 millifarads. Okay, let's check out some inductance then. It's time for henries. So let's start at 1 millihenry. Now I'm going to have to use this crook clip because I can't stretch the tweezers far enough. I actually might need 2. Right, let's have a look. Yeah, if you can see that, that is absolutely bang on at 1 millihenry. Fantastic. Right, 100 millihenries. Yes. 100.4 straight away. Resistance, capacitance and inductance. And this MD2 is excelling at all of them. Yep, 1.007 henries. Fantastic. Alright, so in diode mode then. So yeah, it does give you forward voltage. Now, yeah, you can see the diode symbol just there, indicating the direction of the diode. You can see the diode pointing down there. If I take it off the diode, it'll reset back to neutral. There you go. When I put it on the diode, gives you that indication of the direction of the diode and the forward voltage. That's the only thing so far that I could critique. That symbol there should be in white. So you can see it's too faint. For those of us with not great eyesight, when I do it on the MD1, see, that's a nice clear indication there of the direction of the diode. You can see that straight away. This does do it, but it's a little bit faint. So you can see that symbol. Yeah, you can see it change there. But don't forget, I'm zoomed right in on the camera. So from my normal distance, I can see it. It's there. Maybe I'm being a little bit nitpicky, but I would have liked to see that a little bit more obvious. I use this a lot of the time when I'm building kits, and I use it to demonstrate to beginners the orientation of diodes and stuff, which is not quite so clear on this one as it was on the MD1. That's my only real gripe so far. Okay, so moving on to voltage. Now, this is something that you can't do on the MD1. It doesn't do voltage. So this is a new feature for the ZT-MD2. So it means we get to play with some voltage. Right, you will have to forgive me, viewers, for the incorrect colour test lead here. My black ones all seem to be used up. I have got some more on order. Okay, now obviously I'm testing this with this precision voltage reference, which you wouldn't normally do, but I just want to test the capabilities of this new ZT-MD2. But if you're probing around on a board for voltages, so this will do up to plus minus 16 volts. So if you were probing around on a logic board or something looking for voltages, this is very convenient. Let's have a look at 1 volt straight away. No messing around. 2, 3, yeah. 5. Let's go up to 10. Yeah. And that'll do up to plus minus 16 volts. So you don't want to be using it on high voltage stuff, or you might damage your tweezers. But how convenient for probing around a board looking for voltages. You know, you can check your capacitors, you can check your resistors, you can check your diodes with this thing, and now you can check the voltage as well. Well, that's just pretty darn good, isn't it? There you go. 100 millivolts, not a problem. 10 millivolts, not bad at all. 1 millivolt. Yeah, it's kind of probably on the edge of its limit there. But yeah, it will definitely give you an accurate, fast voltage. Reverse the terminals to simulate minus rail. Okay, so again with the little grey diagram there, to my eyesight that's not overly clear, See, this is plus 10, and you watch, if I reverse the leads to show minus 10, the battery turns upside down to show that you're on minus. Now, maybe it's just me, but I feel like that could be clearer again if that was in white, and just a minus if you're on minus volts. They've done it down there. I love that it gives the high and low. So we've got that. That's nice there, minus 9.987. You can see at a glance what you've got. Maybe a little bit nitpicky, but I think it's something that maybe Zoyi could improve. Maybe a firmware upgrade. I don't know if they can do that on a firmware upgrade, but that would be my comment on it, to make these little grey indications a little bit clearer for the minus volts and for the diode polarity. That's my only criticism so far. Other than that, superb. So one thing I'm intrigued about, the information that came with this suggested plus minus 16 volts, which is what I've been saying through this video. On the listing, it mentions measuring voltages at under 30 volts. But on the display here, it's got plus minus 32 volts. So, let's find out. Let's see what it can do. Let's hook it up to my bench power supply. We're going to limit the current. So, we'll start off at 16 then. Yeah, so obviously 16 it is then. So plus and minus 16, because when you go above 16 it goes red. There you go, as soon as you go over 16 it goes red. So obviously, so I don't know why it says plus 32 volts, minus 32 volts. Of course, one theory is that it's displayed it in red to warn you that there's over 16 volts on the tips. Well, it clearly will go up to 32 volts. That's the most I've got on this power supply, but clearly it will. Whether that's recommended, I don't know, but it obviously it goes in the red when you go over 16. And if you reverse terminals, yeah, again, it just reverses that little symbol there, which you can see what I mean about that little symbol. From a distance, you can easily read that. So if they'd just done a nice white minus symbol there for minus volts, I mean, you can, if you look close up, yeah, you can see the battery's upside down, and then I reverse the terminals and it turns the other way up. Yeah, okay. All right, so yeah, 16 volts is most likely the recommended plus and minus, but as we've seen, it will show up to 30. That's probably not recommended though. See, if you were probing around on a board, testing components out and testing voltages out, this is going to be really, really handy. Because you've got so many functions in one. Probing around a board, looking for little components, even little surface mount stuff. There you go, it's picking that up. Capacitor. As long as you know what you're looking for. I've got an inductor here, look. Got a little inductor there. There you go. These components are so small I can barely see them, and yet it can pick them up. So we've got a little resistor here, picking that up. I can't even see it, but it's picking it up, not a problem. That's really good. And if you had a board powered up that you were just checking for voltages, you can do that. You can check continuity as well with these. So you can do continuity in diode mode. Doesn't seem to have a dedicated continuity mode, this, but that's still pretty handy if you want to check for shorts on a board, and it's pretty fast as well. Same with the MD1. I love the fact that you could do continuity with it. This one has dedicated continuity mode, which you've got there. On this one, it's in with the diode mode, but what I use that for quite often, because my tweezers are always on my bench, is just checking fuses and stuff. Like, it's just so quick, because it's always there, it's always to hand. You can just pick it up and check if a fuse is any good or not. Okay, so what haven't we looked at yet? So here's something cool. We've got this sweep frequency, or scan, as it says there. So if you are testing a component, you can test it at different frequencies. So within the scan mode, you can change the function. You can see it up there, inductance, resistance, capacitance. So if I scan this capacitor here, what it's doing is it's scanning it at all the different frequencies. So it's scanning it at 100 hertz, 120, 1 kilohertz, 10 kilohertz, and 100 kilohertz, and it's giving me the readings there. So you can see the most suitable frequency to be testing that component on. So this is a 2200 microfarad capacitor that I've got in my hand now. So I'd normally test at 1 kilohertz. 1 kilohertz is pretty bog standard, and it's given me a pretty good reading, but different components you'd want to test at different frequencies. It's literally just cycling through. It's updating. Every time it goes through, it's updating, it's updating. So if I tried that on a resistor, there we go, look. So you can see it's scanning through the different frequencies now, and it's giving me a reading on each frequency. That's very cool. I like that. So if you're not sure, for example, what frequency you should be testing a certain component at, well, you can just put it on this scan mode and it will run through them all for you. So we've now got a signal generator mode as well as everything else. Right, well, you know what we're going to need to do now is we're going to need to hook it up to a scope and have a look. So here you go, you can see that we've got the square wave going on there. So now if we change that to triangle wave, you can see there, I've got this set to 50 hertz. It is actually picking it up as 49.99. Yeah, so it's picking it up as near as damn it 50 hertz. Okay, there's a trapeze, there's a half, full, noise. Now you can see what it's trying to do a lot easier, and there's your sine wave. All right, so let's change frequency. So we're on 50 hertz at the moment, so let's go up 60, 70, 80. There you go, and you can see if you keep an eye on the bottom of the screen there, 80, 90, 100. Oh, then we go up to 1 kilohertz. Okay, and it goes up to 100 kilohertz. Okay, it is picking that up as 100 kilohertz. Okay, that's fine. Okay, so let's go back up to wave. Let's put that back on PWM. Right, but now we can change the duty cycle. So on 50% at the moment, 60, 70, 80, yeah, not a problem. Okay, it seems to do what it needs to do. It's not going to replace your main signal generator, but if you just need something that you can use just really quickly just to test something, brilliant. So the other new addition is the ability to have phase angle as your secondary parameter. So let's select that. You can see we've got phase angle there. Now that's going to be handy on capacitors. So with the phase angle, I'm going to take the test frequency down to 100 hertz there. Now, the reason for that is with phase angle, when you measure a capacitor at a low frequency, like 100 hertz, this will behave almost like a perfect capacitor. So you should see the phase angle on this should be near enough 90 degrees. 90 degrees is your ideal. This is measuring at minus 83 degrees, so that's a pretty good capacitor. But you can see if you up the test frequency, so if I go up to 1K, you can see the phase angle won't measure so well. Yeah, minus 53 degrees there. The more you go up, we go up to 10K, you'll see the phase angle will drop right off. Yeah, there you go. See, that's no good. So as you go up the frequency, other factors come into play, like inductance. That causes the phase angle to drop off because this is no longer acting as a pure capacitor, if you will. So yeah, phase angle, don't know how useful that would be to you, but it's another feature that you can use if you need it. Other cool feature now is the hold function, which will actually record the data. So if I'm measuring something, it just uses capacitor as I've got it here. If I want to record that, I press the hold function and it will record that data. The theory being that we can view this on a spreadsheet when we hook it up to the PC, which we're going to do in a minute. Short press on the on-off, it goes into hold, it holds that data. Not only does it hold that data, it records that data, so you can look it up again later on. So if I just do that for these capacitors, then it gives something to look at when we load it up onto the computer in a bit. Okay, so we've looked at pretty much all of the functions now of the MD2, so let's see what happens when we hook it up to the PC. Okay, so I've got the MD2 hooked up to my PC, and it does open as a drive. It opens as drive G on here, and you've got a record.txt. So if you double click on that txt file, there you go. So it gives you a list there of all your hold data. So every time you press hold while you were using the MD2, it saved that result. So you can look back on that. And you can open it like this. If you just double click on it, it opens in Notepad, or you can actually open it in Excel. There you go. And you can make yourself a proper spreadsheet out of it, which is quite handy. So what do I reckon then? Is the ZT-MD2 worth it? Yeah, absolutely. Absolutely. This is a really, really excellent bit of kit. I mean, we've come to expect quality stuff from Zoyi. I've looked at a few Zoyi products now, and they've always been good and really good value for money. This is the thing. They're not mega money. So you can pick these up. I think you can pick these up for like 20, 30 pounds on AliExpress, and this is about 40 pounds, I think, at the moment. There's various deals around, so worth shopping around for the best deal. But yeah, I'd say big improvement on the MD1. Only two little downsides for me. If they could just improve this little symbol here. I think if they could just make that a little bit clearer. That's the only things really I've found about it. It sits quite nicely in the hand. I will say the tweezers operate a little bit easier than the MD1. With the MD1, you need a little bit more pressure, on my one at least, to operate the tweezers. These are a little bit easier. The screen's a bit bigger. If it annoys you the fact that it turns around the display like that, you can turn that off in the menus. I find that's quite handy for me, because sometimes I find myself using it upside down or weird angles when I'm trying to look at a board. So I find that's quite handy. I'll leave that on for now and see how I get on with it. But yeah, I definitely think they're worth the money. I think they're definitely worth having. They are slightly faster, slightly more accurate than the MD1. Not a huge amount in it. Both really good LCR tweezers. Well, there you go, the ZT-MD2 LCR Tweezers from Zoyi. It was inevitable I was going to draw a comparison to the MD1, as I use these pretty much every day. They're a staple of my toolkit. They're always on my bench, and they're just so handy just for checking out bits and bobs, and for when you're building kits as well. But yeah, I'd say the MD2 is a great upgrade. You've got a slightly bigger screen. The fact that it turns around automatically if you're right or left-handed, that's very handy. I like that. It's got some interesting new features as well. The ability to measure voltage up to plus minus 16 volts, as we've seen. You can push it beyond that. It's got the signal generator, and it does phase angle now, plus you've got the increased test frequency up to 100k. It's very accurate and it's very fast. I'm really impressed with it. We've seen a lot of good products from Zoyi recently, and this is another one. It's not even a mega amount of money either. If you want to check out the MD2 for yourself, I'll leave the link in the video description down below. And big thanks to Zoyi for sending me over these LCR tweezers to review. So I hope you've enjoyed today's video looking at these LCR tweezers. As always, massive thanks to everyone for watching, sharing, liking and subscribing. And big thanks to all my YouTube and Patreon members. Don't forget, you can also support me on Patreon and buy me a coffee, which helps to support the channel and keeps me making more videos. I'll be back soon with another tech related video, but in the meantime, take care and I'll see you on the next one.